And now for my favorite use of the apply operator. Welcome to this video on the apply operator. My name is Kevin Fiesel, and I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. So far, we have used the apply operator to query other tables, whether for the purposes of pre-aggregation or to retrieve child records. But it turns out that you don't need to query a separate table in order to use the apply operator. In this case, it's probably better for us to jump straight to the demo, so let's go. Here we are in Visual Studio Code. Today's demo involves one query, but it's a bit of a doozy, and I think it represents the kind of reporting query that we often see in practice. The accounting team for Wide World Importers is interested in understanding what would happen if they made certain changes to their business model, so they want us to build a report to help them understand the consequences of their plan. I have some basic rules here. Any order over $4,000 gets a 5% discount. If the order is over $8,000, the customer gets a 10% discount instead. These discounts, of course, do not stack. Also, we negotiated new terms with our carrier. Under these new terms, any order that weighs less than 3 kilograms ships for free. But if we have an order heavier than 3 kilos, it costs $5 plus 20 cents per kilogram to cover the price of shipping. As part of our customer experience, it is Wide World Importers policy that we do not pass on these shipping costs to customers, though the accounting team would like to know how much these new terms of carriage will affect our bottom line. With these rules in place, what the accounting team would like to see is a series of measures that I've defined here. We have revenue, which is retail price times quantity sold. Net sales is revenue minus any discounts. The cost of goods sold is our unit cost times the quantity sold. Shipping expenses will be the total of any shipping costs which are not part of costs of goods sold. Gross profit is net sales minus cost of goods sold, and gross profit margin is gross profit divided by net sales. Finally, net income incorporates shipping expenses. This is still a mild simplification of a proper accounting system, but as you can see, we have some interconnected calculations that we will need to manage. I've decided to tackle this report in sections so that we don't get too lost in the weeds. Also, this first attempt will not make use of the apply operator. I'll get to that version after we see the non-apply version. For the first step, I'd like to calculate the revenue by month. I have two notes here. The first is that the column on invoice lines called unit price is our cost for that item. Meanwhile, line profit is a column that describes the difference between our final retail price and the full cost we pay. Thus, if I want revenue, I need to take line profit and add to it the unit price times the quantity, as our unit price is a per unit calculation and our line profit is across all units in the invoice line. I'm joining this to a calendar table that I've created in order to make displaying the year and month much simpler. Incidentally, Wide World Importers does not ship with a calendar table in it, but I have a video in which I share one script I've used in the past to create calendar tables. I'll include a link to that video and the script I've used in the description below. Running the query, we can see that it does work, and I get back revenue by year and month. Great. One calculation down, 6 to go. Our second step is to calculate net sales on a per month basis. As a reminder, this is where we would need to add in any rules around discounts based on total order revenue. To start things off, I'll incorporate a slight modification of the first step's revenue query in a common table expression that I'm calling orders. This gives us, for each order ID and date, the sum of revenue for that order. Then in the base query, I take orders and join to the calendar table. In the select clause, we can see my calculation of revenue as the sum of revenue for all orders. We also want to calculate the discount amount, which I can do using the sum function and a case expression. After that, I need to calculate net sales, which is the revenue minus any discount amount. Notice how in my calculation for net sales, I need to repeat the formula to calculate discount amount. This will be an ongoing theme. By the time we're done with this step, the code is still readable, but imagine if the accounting team decided to add an intermediate discount for orders of $6,000 or more. In that case, we would need to change the code in two separate places, and this can introduce bugs. Nonetheless, as I run this query, we can see that the code does work and we end up with the revenue, the discount amount, and net sales. Now let's move on to calculating cost of goods sold by month. We already know what cost of goods sold is. It's unit price times quantity. Let's add that to the order's CTE. But again, there's some more duplication. I need to multiply unit price times quantity two separate times in this common table expression. Fortunately, as I move down to the base query, there's nothing special I need to do with costs of goods sold, so I can simply add it to my base query, summing across year and month. In the next step, we'll calculate shipping expenses. As a quick reminder, any order under 3 kilograms in weight, or 6.6 freedom pounds, ships for free. For anything over that weight, we have to pay a flat fee of $5 plus 20 cents per kilo. If the weight is over 3 kilograms, there is no discount for the first 3, so we do not need to take that into consideration. In our common table expression, I have revenue and cost of goods sold, but now I need to calculate the total weight. To do that, I'll use the invoice line's quantity to get the number of items that we're shipping and multiply that by the typical weight per unit in the stock items table. This gives us an estimate of how much things weigh, and it's good enough for this scenario. Now we have the total weight for all of the items in our order, so let's move to the main query. Below cost of goods sold, we have a new calculation for shipping cost. In this, we have another case expression where if the weight is less than or equal to 3 kilos, the cost is 0. Otherwise, we calculate the shipping cost based on our flat fee plus the weight for the order. We otherwise don't care about shipping weights, so I won't include that in the final query. Let's run this query and make sure that everything is still fine. And after a moment, it completes and we see our results. As I scroll through the results, it seems that shipping cost is a very small percentage of either cost or revenue, hitting the low 6 digits versus a cost of goods sold that has 8 digits, meaning our anticipated shipping expenses would increase our costs by approximately 1%. It's not a tiny increase, but the discounts we are offering swamp the shipping costs. Next up, let's calculate gross profit. We calculate gross profit as net sales minus the cost of goods sold. Our common table expression already has everything we need, so I can move on to the base query. In here, we have one new line, and I need to scroll over to see the entirety of it. It starts out exactly the same as net sales, in which we sum the revenue minus any discounts. Then we take that sum and subtract the sum of cost of goods sold. Fortunately, these are both additive measures with respect to date, so I can safely aggregate and then subtract rather than needing to calculate anything on a per order basis. I can run this query and get back my results. Once again, the query runs successfully and I do get my results. But I hope you're starting to feel as squeamish about this query as I am. If our discount amount formula changes, we now have 3 places to update it. In step 6, we are nearing the finish line, but we still have a little bit more to do. I now want to include gross profit margin. This is gross profit divided by net sales and acts as a percentage representation of how well we are doing financially. My common table expression is still the same as before, but the base query has become even more complicated. We can see that the calculation for gross profit margin now spans 2 lines. The top half of it is our calculation of gross profit, which is net sales minus cost of goods sold. The bottom half is net sales. And if you're keeping track of those discount calculations, we are now up to 5 copies of the formula. Once again, the query does work, and we do get our calculation of gross profit margin, which is about 30% per month. I will commend the people who put together the Wide World Importers database, as in my experience at least, healthy retail companies do tend to have a gross profit margin of approximately 30%. Of course, as we've seen so far in this query, gross profit margin only includes cost of goods sold and not other costs such as plant, employee wages, benefits, loan interest payments, taxes, and so on. That's what we typically calculate with net income. Now, I don't have employee wages, benefits, taxes, and the like in this database, so we can't get a proper net income, but what I do have is those shipping costs. So we're going to take gross profit and subtract shipping costs to give us our pseudo net income. The common table expression is still the same as before, so that should tell you that the base query is where we can find our changes. Scrolling down, I have one mighty long line that includes net sales minus cost of goods sold minus shipping costs. Running the query, we can see that it does work just the way we would expect, so that's good. But imagine having this report in production and then the accounting team wants to make some changes to the discount amount formula. Even if those changes are not particularly complicated, the sheer number of times we need to make the change is a risk factor of its own. The new guy on the team updates this and tells you he changed all 5 instances of the formula and everything looks great. The query runs, the numbers look pretty reasonable, and you ship it. But then the accounting team says that something doesn't look quite right and they need you to review the procedure. That's when it hits you. There weren't 5 places with the discount amount. There were 6. Well, that's really painful. So let's see how we can use the apply operator to reduce the level of pain and make this query a lot easier for you to read and for the new guy to maintain. Let's start with this common table expression. If I look at the final CTE for step 7 of the old query, we can see some duplication between the calculation of revenue and cost of goods sold, specifically multiplying unit price by quantity. This is not particularly egregious, and I'm likely to leave this alone in a real-world scenario, but because we're in demo land, we are going to fix that. Let me scroll down to the new common table expression. The from clause and joins look very similar to what we had before, but down at the bottom, we have a cross-apply operator. Inside of here, we have a select clause that takes unit price times quantity and calls that unit cost. Notice how I do not have a from clause here. I'm not separately querying the invoice lines table. Instead, I'm referencing invoice lines as the input and defining a mathematical formula as the output. I can reference this unit cost using the alias of C. In the select clause, we have 2 places where I reference unit cost. I'm no longer duplicating a formula that I might get wrong. Instead, I'm referencing a column, and those column references will always return the same thing. That's pretty neat, but as I scroll through the main query, we can see that this is where I really need the help. So let's get to fixing. In the next step, I want to simplify the main query. My common table expression is still here, and I don't need to change it. Now let's scroll down past the select clause and into our from clause. We drive from the orders common table expression and join to the calendar table just like before. But then I start the first of a series of cross-apply operations. The first one I've called calc. In it, I define 2 calculations, shipping cost and discount amount. These are my 2 case expressions, and the good part about putting them here is that if the formula for discount amount or shipping cost ever changes, I can change it in this one location and that's it. Next, I have another cross-apply that I call calc2. It gives me the formula for net sales, which is revenue minus discount amount. Notice how I can reference the calc virtual table in calc2. That's because, as far as the apply operator goes, any virtual table you include prior to the apply operator can act as an input to the function we call in apply. Thus, we can chain together functions in this way, building things up. That's why in Calc 3, I can reference net sales from Calc 2 and then subtract cost of goods sold from it to give me gross profit. With these 3 ad hoc functions in play, let's scroll back up to the select section and see how things look. Notice how much easier this is to read compared to the prior version. Even complex measures like gross profit margin and net income become simple division and subtraction, respectively. But how do these 2 versions perform? That's a good question. Although the apply operator version is considerably easier to read and maintain than the original version of this query, if it performs markedly worse, we might still want the more complex variant for speed reasons alone. In order to test these, let's take the final forms of each query and go to SQL Sentry Plan Explorer. In Plan Explorer, I have a new plan window already open and ready for us. I'll paste in the query text for both of these and give them a run. Now, it will take a moment for these two to complete, but soon enough, we'll have a pair of plans. It turns out that the execution plans between these two variants are the same. There are some minor differences in duration, CPU utilization, reads, and memory grant, but I'd chalk most of those differences up to whatever else is running on my PC at this time. In practice, there is no practical cost to using the apply operator in this way to perform calculations. It won't make your queries faster, but it also won't make them slower. It will, however, make them considerably easier to read. But before we go, I do need to talk about some limitations that you'll find in using the apply operator to perform calculations. Here's an example of the insides of our common table expression that we had before. We can see the cross-apply operation generate a virtual table that we've aliased as C, and it includes the formula for unit cost. But you know what would be better? If we could perform that aggregation inside of our apply operator. That way, we would have cost of goods sold, and we could simply subtract it instead of needing to aggregate. But if I run this query, we get an error. This error may appear to be nonsensical at first, as we don't have an on clause with an aggregate. But this is basically saying that we can't aggregate multiple input records into one output record like we're trying to do here. Apply runs once for each row in the input set, so even if we did not get an error, we'd still get unexpected results. And I can prove that to you. Let's go to this next query, in which I'm calculating the row number for each customer order within a given month. I am partitioning this by customer ID and ordering by order ID ascending. Looking at data for a single month, we can see multiple order IDs for customer ID 1. What I'd really love to do is get the first 5 orders for each customer in September of 2016. But I can't add row num to the where clause because it does not exist at the time we resolve the where clause. In other words, where resolves before select, so I can't use the output of the select clause as the input to my where clause. That's why in the child records video, I used a common table expression and included the row number function inside of it. Then in the base query, I could reference row num in the where clause as the common table expression is logically distinct from the base query. But what if we made use of what we learned today and include row number in a cross-apply operator? Well, I can run this query and it will generate results for me. But these results are not what we expected. The reason we get back 1 for each row num is that we execute cross-apply once for each input row. But things are even more interesting than that. Let's take this query and copy it, along with the actual working query, into Plan Explorer. In a new plan window, I'll paste in these 2 queries and then execute them. It will take just a moment to complete, and we'll get back a pair of execution plans. I don't care about the performance at all. I just care about how the database engine solves these 2 queries. I'll start with the common table expression version. In here, I have a scan of the calendar table and a scan of the orders table. We hash match these together. Then I have a sort, segment, and sequence project combination. After that, we filter to include only the rows where row num is less than or equal to 5. This plan makes a lot of sense, especially in light of the prior video on getting child records. Now let's take a look at the apply version. This query plan is very different. It starts with a constant scan, followed by segment, sequence project, top, and filter. That's basically telling us that we are not actually sending the customer ID or order ID into the row number function, as all of this happens prior to querying the orders table. Our row number will always return 1 because it is effectively a degenerate function. It doesn't take the input into consideration at all. Then we have our 1 output row and perform a nested loops join to connect it to our orders. This gives us something that is technically valid, but completely useless for our purposes. Long story short, if you are using a window function, do not try to simplify the window function by using the apply operator. You can certainly use the window function in an ad hoc function that includes a from clause, but it won't work correctly in the scenario in which we do not have a from clause. And that's going to do it for this video. Hopefully, I've given you a solid idea of when you can and cannot use the apply operator to simplify calculations. I've made great use of this capability to tame wild queries and make them easier for developers and database administrators to understand. As we saw, we cannot aggregate or use window functions within an ad hoc function that does not include a from clause. Or at least we can't simplify calculations in quite the same way. But even so, there's a lot of power in the apply operator's ability to simplify calculations, and it comes with no real performance cost. In the final video of this series, we'll take a look at ways to reshape datasets using the apply operator. We'll have links and show notes in the description below, and until we see each other in the next video, take care.